Completed? Okay. Next, if small d is a 0.32 millimeter, lambda I'm using 5500 nanometer, then minus 30 degree is less than or equal to theta less than or equal to 30. I'm asking the total number of bright fringes in given range. Maybe this time, this is a new problem already. Maximum I asked how many total number of maximum bright fringes we can get on the screen. This question is based on that concept only. So here the distance between the slit I gave 0.32 millimeter and the lambda I gave 500 nanometer. Now I am asking in the range of minus 30 to plus 30 means, if you remember, I said in YDSE what pattern we are getting above the bisector, same we will go get below the bisector. Only one difference will be there. Above bisector S1 path is less, S2 path more. Below the bisector S1 path will be more, S2 path will be less. But if I am getting the first minima above, then I will get first minima below also. First minima, second minima, then second minima. Same pattern we will get above and below. That's why they are saying minus 32 plus 30 means like this. Suppose this is the YDSE setup. Means this you are taking 30, then this you will take minus 30. So minus 30 to plus 30, how many total number of bright fringes you will get? They are asking. Okay, how we will calculate? When they given theta, then I can find is at this 30, at this angle 30, which maxima I am getting. At this angle 30, which maxima I am getting. According to that, I can calculate the total number of maxima. So what is the boundary they given? 30 degrees. So boundary first I will check how many maxima I am getting. Then I will use what? D sine 30 is equal to bright they are saying, so I will use maxima condition L lambda. Okay, D they given 0.32 millimeter means 10 to the power minus 3. Sine 30 means 1 by 2. Lambda shift down 500 nanometer means 5 into 10 to the power minus 7. That is equal to N. Now 5 to the 10, it becomes 10 to the power minus 6. That goes up plus 6 minus 3, 3. Then what you got? N is equal to 320. Okay, N value I got 320. But suppose after putting the sine theta is equal to 30 degree, N value suppose you are getting 320.9. What you will take? Suppose N value you are getting 320.9. What is the N value you will take? Tell fast. If you are getting N value 320.9 suppose, then what is the N value you will take? $320. Why? Because we cannot exceed the 30. We can, like this type of concept we have discussed in the organ pipe also. We cannot exceed the 30 degrees. That's why we have to take the lesser integer. So closer integer is what? 320 we will take. Okay. Now N value I got, suppose directly here I am getting integer, N value I got 320. Means at that 30 angle, which maxima, which bright I will have? 320. Okay. Then total number of maxima how I will get? How many I will get? 641. Total number of maxima how many I will get? 641. Why? This side 320, below the bisector also 320 and one central maxima. Then total number of bright you will get what? 641. $320 above bisector, 320 below bisector plus one central maxima. Then how many you will get? 641. Understood? Completed? Tell fast. Tell fast. What is the answer? I'm asking the mu. This type of question we have done in the class also. One point five, 1.5, 3. How you are getting 3? When I'm saying same point, in same point means y same or theta same means path difference will be same. Path difference same, then I can equate the delta x1 in the air, delta x in air, that will be equal to delta x in medium. Now delta x in the air I'm getting the third maximum is 3 lambda air. That is equal to what? Fifth minima. So then I will write 2 into 5 minus 1. And minimum lambda by 2, so lambda medium by 2. Now this I got 3 lambda air, that is equal to what? 9. Lambda medium I can say lambda air by mu. This we have learned in the optics and so many chapters. Now lambda air cancel out. 3 3s are 9. Then what is the mu you got? 3 by 2. Okay. Now last problem. If in the front of the slit, thickness T, refractive index mu, a slab of thickness T and refractive index mu introduced, then central maxima shift by 1 bright. Then find T if wavelength is equal to lambda. Tell fast what is the answer. When we are putting the slab in the front of one of the slit, then what is happening? Extra path is coming in that slit. So that central maxima will not be at the bisector. It will shift towards the slit in the front of which we have introduced the slab. 2 into 5 minus, because fifth minima, for the minima what is the path difference? 2n minus 1 lambda by 2. So fifth minima I said, that's why 2 into 5 minus 1 I took. Understood? Now here, what is that in this question what I can do? Due to the slab extra part difference, what is the part difference is coming? That you have to remember T into mu minus 1. That T into mu minus 1, if they have given the number of bright shifted, we will equate with N lambda. If they have given distance shifted, we will equate with dy by capital D. So here how many bright shifted? 1 bright shifted. Then now what is the T you got? Lambda by mu minus 1. This question asked in the JEE main. Everybody got lambda by mu minus 1. Okay. Now YDC over. Then in a similar question we have done when we are using the electron beam and velocity of electron increase. So when they are saying in the place of light we are using electron beam, then we will relate with the de Broglie wavelength. Lambda increases, fringe width increases. Okay. When we are replacing the red light by blue light wavelength is lesser, that's why the fringe width will decrease. When we are using the white light in the place of the monochromatic light, then we will get the bisector is white. Near to the white, we will get the minima of the violet. Means near to the white spot, we will have the red color. Which minima will be observed which minima will be there near to the central white? Minima of the violet. Why? For the violet lambda lesser, so minima will be closer. Okay. Now single slit diffraction. First thing, what is the diffraction? Diffraction is basically, I said what? Spreading of the light from the small opening of the small obstacle. Okay. If one thing I discussed in the regular class, we can observe it is easy to observe the diffraction of the sound or diffraction of the light. Whose diffraction we can observe easily, or we can observe the nature diffraction of sound or diffraction of light. So if you remember, I said for the diffraction, obstacle or the opening must be the comparable to the wavelength, not light, comparable to the wavelength. Wavelength of light is very small. So means we can get the diffraction of the light when we are taking the small opening. Suppose a small opening in the home. Suppose you have the small opening. When the light is going, parallel beam of light is going, it appears as a beam. It appears as a parallel beam. But when the light is coming from very small hole, then you will see the spreading of the light. So for the diffraction, opening must be small or it is comparable to the wavelength. Now for the light, we require very small obstacle. Why? Wavelength of light is very small. So that's why in the nature we will not observe, like in the room or somewhere, you will not observe the diffraction of the light. But sound wavelength is large. Sound velocity in the air is 332 meter per second. So its wavelength is large. So sound will get diffract from the small in the large obstacle also. Why the wavelength will be comparable to the obstacle size. Okay, that's why easily we can observe, like in the classroom also we are getting the different diffraction from the different object. So sound diffraction we can easily observe, but not light. Okay, so that wavelength is more, then it is easy to get the diffraction or more distinct diffraction you will get. That I said in the regular class also. Then now, what is the diffraction in the single slit diffraction and the interference? In the interference through the double slit, we are taking the two coherent wave. One wave is coming from the S1, one wave is coming from the S2. So we are taking basically the superposition of two coherent wave. But in diffraction through the single slit, what I said, so many point charges, so many point sources are there. All are behaving like a source. So basically, diffraction is the superposition of large number of sources. Why? In the width of the slit, so many points are there. So on the screen, they are superimposing. That's why it is a large number of sources are meeting. Width of the slit, I took the A. From the central, I have taken the O. Then angular position, I have taken theta. First minima, second minima, like that. Okay. So diffraction is the single slit diffraction. It is a superposition of the large number of the sources. That is the one difference. Second, in interference, all the maxima are equally bright, all the minima are equally dark. Means whether I'm saying first maxima, whether I'm saying second maxima, all maxima have equal brightness. Okay, all minima has equal darkness. But in the diffraction, central maxima will have the maximum intensity, then first maxima lesser intensity, second minima more lesser, then continuously intensity will decrease. That is the second difference. Third, I said, in the interference, we are defining the fringe width. Any two consecutive maxima, that is called the fringe width, and that will remain constant throughout. Okay. But in the diffraction, what is happening? Central maxima width is the double of the other maxima. Central maxima width is the 2 lambda by A angular width, I said. Okay. So that is the third difference we can say. This everybody got? Now after that, For first minima, if angular position I am taking here theta, then we got the condition is what? A sin theta is equal to n lambda. Here condition is getting reversed. For the minima we are getting the n lambda. N is the number of minima. N is the number of minima. Okay. For small theta we are using what? A theta is equal to n lambda. So first minima, like this here they ask in the JEE main, what is the angular position of the first minima? Directly you can say, what is the angular position of first minima? What is the angular position of first minima? Lambda by a. Why? Theta is equal to first minima means lambda by a. Second minima 2 lambda by a. Third minima 3 lambda by a. What is the angular separation between the first and third minima? Angular separation between the first and third minima. Angular separation between 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 first and third minima, 2 lambda by a, 2 lambda by a. Why? First is the lambda by a, third is the 3 lambda by a, so angular separation between them is the 2 lambda by a. Very good. Okay. Then for maxima, what is the condition we learned? A sin theta is equal to 2n plus 1 lambda by 2, where n is the number of maxima. Like first maxima, we will take the n1 like that. Then for small theta also we can say a theta is the 2n plus 1 lambda by 2. So when they have not given the angle, we will take the small angle only. Okay. Now what is the angular width of the central maxima? Angular width of central maxima. So like this is the screen, this is the slit. Then on the screen we are getting here first minima, then here we are getting first minima. In between this is the width of the central maxima. This angle we are getting 2 lambda by a and the distance is capital D. Then same formula we can use here, like angle is the 2 lambda by a, so this length if I am asking, if I have given the angular separation, angular fringe width, then we will say 2 lambda by a. What is the width of the central maxima? If I am giving the option in the radian or degree, it means I am asking the angular. Angular is what? 2 lambda by a. But if I am asking the linear width means option I have given in millimeter or centimeter, then linear width I can say what? Linear width is equal to 2 lambda by a angle into radius. Radius what I will take? Capital D. Like the fringe width, capital D lambda by small d, here capital D lambda by small a. Okay. Up to this, okay. Okay. Like you can remember. Okay. This over. Now capital D lambda by small d, similarly here we are getting capital D lambda by small a. I said what? When they are not given the capital D, they are saying that we are using the convex lens to focus the light on the screen. Then capital D we will take the focal length. Capital D we will take the focal length. So when they have given the convex lens of focal length f to use, they are using to focus the light on the screen. Then in the place of capital D we can use the small f. In the Fraunhofer diffraction, mainly we are doing the Fraunhofer diffraction. Fraunhofer diffraction, the light rays coming from the far object. Far object means parallel beam of light is coming. Parallel beam of light means what is the shape of the wavefront? Planar. Okay. So if they are saying in the single slit Fraunhofer diffraction, what is the shape of the incident wavefront? Planar. What is the incident wave? Parallel beam of light is falling. Okay. So one question you will say. Tell fast. If the angular separation of the second minima I gave, I'm asking the angular separation of the first minima. If the options I am giving, tell fast, what is the answer? $30, 130. Good. Next. 30. Most of the students are saying 30. Directly half. First minima, directly half. And directly we can do the half when the angle is small. When angle is small like theta, so first we are getting the lambda by a, second we are getting 2 lambda by a. For the small angle, directly we can do the half. But here, this angle 60 degree, they have given large. I cannot go to the a theta is the lambda, a theta is the 2 lambda. So listen now. A sine A sine 60, then I will write second minima they given, so 2 lambda. This is what? Second minima. Then sine 60 is the root 3 by 2. So what is the A? You will get 4 lambda by root 3. Now after getting the A, now they are asking for the first minima. Now first minima, what I will say, A sine theta is equal to lambda. That is for first minima. Now A, what we got, 4 lambda by root 3 that into sine theta is equal to what? Lambda. Lambda cancel out, sine theta what you got? Root 3 by 4. After that, common sense you have to use. Root 3 by 4, it is a more than 1 by 2 or less than 1 by 2? It is a less than 1 by 2. Why? Root 3 is the 1.7. 2 by 4 is the 1 by 2. 2 by 4 is the 1 by 2. But this value is coming less than 1 by 2 means less than 0.5. Less than 1 by 2 means angle has to be lesser. Angle will be less than, because sine 30 is the 1 by 2. But I'm getting the less than 1 by 2 means angle will be less than 30. Angle will be less than 30, then only one option we have. What? 25. Okay. And even you can calculate the approximate value also. Root 3 for the small angle like 30 degrees also the small angle we can take. Sine theta can be written as theta for the small. This is less than 30. This is the less than 30. Then you can say theta. Sine theta can be written as theta. Theta is the root 3 by 4. Theta is the root 3 by 4. But that root 3 by 4 is in the radian. To get the degree, multiply with 180 by pi. When you multiply with 180 by, you will get approximately 24 point something or 25. Here, sine theta, theta is the less than 30, so you can take a small sine theta can be written as theta. Theta you got root 3 by 4, but that is in the radian. Now multiply with 180 by pi, you will get in degree. You can check also. That will come approximately 25. Okay. Completed. Now listen. Suppose I am saying the light is coming from the sun. Light is coming from the sun. Sun means far. Then parallel beam of light will come. We have the one pinhole. pinhole means you have taken the pin or you have made the hole. Basically, it is a single slit. There is a pinhole, light is coming from the pinhole. Okay. When we increase the size of the pinhole, what is the effect on the diffraction? Like then they given the option on increasing the size of the pinhole, then width of the diffraction will decrease, intensity will increase. Width of the diffraction will increase, intensity decreases. Both increases, that option they given. So when they are increasing the pinhole means single slit, they increase the size means A increase, A become more, then all the width will decrease. Why? 2 lambda by A into capital D, lambda by A into capital D. So what will happen? Width of the diffraction will decrease. So width will decrease. But when we increase the size of the hole, more light will come, then intensity will increase. That point also you have written the note. Everybody got? So intensity will increase and the width of the diffraction will decrease. Understood or not? Then now polarization. Polarization means on which phenomena, we can say on which phenomena we can decide the transverse nature of light, or we can differentiate between the transverse wave and longitudinal wave. So that is what polarization. On the basis of polarization, we can differentiate between the longitudinal and transverse wave. How? Then suppose the wave is going, you put the one polarizer in the path of the wave. Suppose that intensity of the wave is changing by the rotation of the polarizer. Okay, intensity of the wave is decreasing or increasing on the when it is passing from the polarizer. So it means it is a what? It is the transverse wave. When there is a no change in the intensity, then we can say it is a longitudinal wave. That's why we say transverse wave can polarize, but longitudinal cannot. Okay. Then what is the meaning of the plane polarized light or linearly polarized light or the polarized light? So basically, listen carefully. Our eye in the light is the EM wave. In the EM wave, electric field and magnetic field vectors are there. Our eye is what? Sensation of vision, means how we are able to see any object. So sensation of vision comes due to the electric field component of the light. Means due to the electric field component of the EM wave, we can see the object. Okay. So when we are saying the light get polarized, so which component we are talking about? Electric field component we are talking about. We are not talking about the magnetic field component. Okay. So when suppose I am saying unpolarized light means the oscillation of electric field in the different plane, like it is oscillating like this, it is oscillating like this, it is oscillating like this, it is oscillating like this. So where in the different plane oscillation lies. Okay, so it is the unpolarized light. It is the unpolarized light means the oscillation lie in the different planes are there, like this plane, this plane, this plane. Now what is the meaning of plane polarized light? When oscillation, whatever the remaining oscillation or all oscillation, they lie in the same plane. Whatever it is, like this plane, all oscillation lie in this plane, or all oscillation lie in this plane. If all oscillation lie in a single plane, that is called the plane polarized light or linearly polarized light, we can say. So what is the unpolarized light? When different oscillations of the electric field components are in the different planes. It is the UPL, unpolarized light. When all oscillation lie in one plane, it is called the PPL. Okay. The device we use for that, it is called the polarizer. Polarizer is what? Nicol prism, tourmaline crystal, we can use as a polarizer. Okay. Then suppose unpolarized light of intensity I0, it fall from the polarizer. Okay. Then what will happen? When UPL will pass from the polarizer without thinking anything, without thinking about the orientation, what will transmit? It will transmit half of the intensity. It will transmit half of the intensity. Okay, so means 50%, first polarizer will absorb 50% of the light. Okay, and it does not depends on the orientation, only orientation, which quantity will depends on the orientation. So according to this you have put, you will get the oscillation here. Suppose you put the path axis like this, so this oscillation only you will get. If suppose you put the polarizer like this, then this is the path axis, then only this oscillation you will get. Means what is the orientation? According to the orientation, we will get the PPL. We will get the PPL. If this is the what? Orientation, then we will get the white one. If green is the orientation, we will get the green one. But with in the first polarizer, what is the intensity transmitted? I naught by 2. That will not depends upon the orientation. Understood or not? Okay, now after that you will have the PPL, that plane polarized light whose axis is parallel to the first polarizer. Okay, now it passed from the another polarizer. It passed from another polarizer. Suppose the angle between first and second is theta. Then when you have the PPL, and then that PPL is passing from the different polarizer. So when you have PPL, then transmitted intensity, you will apply the Malus law. What is the Malus law? Whatever incident into cos square theta. What is the theta there? Angle between the path axis of polarizer. Angle between path axis of polarizer. Like here, first polarizer, without thinking, you have given I naught by 2. Now I naught by 2 incident on the second polarizer. What it will transmit? It will transmit incident. Incident is what? I naught by 2 into cos square theta. Theta is the angle between their path axis. One path axis is this path axis is this. What is the angle between them? Theta. So what it will transmit? Cos square theta. Okay. Then suppose third polarizer I kept like this. So I already said when the angle between the path axis of the two polarizer is 90 degree, then they called crossed each other. They called crossed each other. What is the meaning of crossed each other? When the angle between the path axis of the two polarizer is 90 degree, then they called crossed each other. Why they called crossed each other? Because in that case, suppose this is the light it is transmitting, it will transmit this one. Okay, what is the component of this light in this direction? So these both are perpendicular, so there is no component of this light in this direction. So in that case, transmitted intensity, what you will get? 0. That's why they called crossed each other. So when the angle between the path axis is 90, then the polarizer called cross each other. So here P1 and P3 crossed each other. P1 and P3 crossed each other. Then how much it will transmit? Now up to the second I got I naught by 2 cos square theta. So what is the incident on the third? Incident on the third is the I naught by 2 cos square theta. Then incident into cos square theta. Incident into cos square theta, where theta is the angle between the axis of these two. Now what is the angle between axis of these two? Its axis is this and its axis is this. Then what is the angle between them? 90 minus theta. Then here I will put what? Incident into cos square 90 minus theta. From this, if you remember result, I said also I naught by 2 sin square theta cos square theta. Otherwise you can write I naught by 8 sin square 2 theta. I think somebody remember also this result. Tell fast, yes or no? Okay, so at what angle the transmitted intensity, what is the value of theta for which transmitted intensity will be maximum? For what value of theta transmitted intensity will be maximum? For what value of theta transmitted intensity will be maximum? We remember I naught by 8 sin square 2 theta. No problem. Separately also you can remember. Otherwise, after multiplying 4 and dividing with 4, we got this 45. Okay. The same question came in the JEE Main this year. For what value of theta transmitted intensity will be maximum? So theta will be 45. Okay. Now next question you will say. Read symbol carefully. Like I'm using for the UPL is the I naught, but maybe they will say the transmitted intensity is I naught. Then don't take the incident is the UPL is the I naught. Otherwise I naught you will cancel. You will say 8 is equal to 1. So which symbol they are using, we will not use that symbol. Okay, like they are saying that transmitted intensity is the I naught. Then UPL I will not take I naught. I will take another symbol. Okay. Find transmitted intensity. Tell fast. What is that transmitted intensity if the angle between 1 and 2 is a 60 and 1 and 3 crossed each other? Third, 3 I naught by 16. Something you are missing. Something you are missing. Something you are missing. I naught, 3 I naught by 32. 3 I naught by 32 is the answer. Here you will get I naught by 2. Here you will get I naught by 2. Cos square 60. Cos 60 is the 1 by 2, so you will get I naught by 8. Now here what you will get? Incident I naught by 8. I naught by 8 into cos square. Now what is the angle between these two? This two angle is what? 30 degree. Then we will directly write cos square 30. Cos 30 is the root 3 by 2. So square you will get, so 3 by 4. Then you will get 3 I naught by 32. Okay, if they are asking percentage transmitted, then we can say what? IT transmitted upon incident. That is equal to what? 3 by 32. Now percentage transmitted multiply with 100. So around 9 point some percent means approximately you can say 10% transmitted. So how many total absorbed? 90% total absorbed. Okay. Then now that is a small topic. This is the Brewster law. Brewster law is what? First we have to know the definition. What is the polarizing angle? Polarizing angle or Brewster angle. So when the light incident on the interface of the rarer and denser medium at particular angle of incidence, reflected ray is completely polarized. That angle of incidence is called the polarizing angle or Brewster angle. And the plane of polarization of the reflected ray is the perpendicular to the plane of oscillation, perpendicular to the plane of incidence. Like this is the boundary of the rarer and denser. This IP, angle of incidence is IP. So then reflected ray, if you remember, I made the dots. It means reflected ray is completely polarized. Dot means what? Into the plane. It means the oscillation plane, polarized light oscillation is what? Into the plane. Incidence plane is the board plane, and oscillation of the reflected beam, plane polarized beam is what? This into the board. Into the board means it is a perpendicular to the plane. That's why I said plane of polarization. Plane of polarization means all oscillation lie perpendicular to the plane. That's why plane of polarization is perpendicular to the plane of incidence. Who will get completely polarized? reflected ray will be completely polarized at polarizing angle, and at polarizing angle refracted ray and the reflected ray are perpendicular to each other. By using that relation we got the mu is equal to tan IP, okay, where mu is the refractive index of denser medium. If denser, rarer they have not given air, then we can use the mu upon mu r is equal to tan IP. So in the place of the mu 1, denominator 1, I can take the mu r, okay. Everybody got? Then I said the range of the polarizing angle, because mu is the refractive index of the denser medium. Denser medium refractive index will be more than 1. That's why polarizing angle will be always more than 45. Polarizing angle will always come more than 45. Okay, and less than 90. That is the range of the polarizing angle, 45 to 90. Then remember all this, that point is more important because theoretical question they can ask from the Brewster law. After that formula mu is equal to tan IP only you have to remember. This type of question I have discussed. Suppose we are putting the polarizer in the path of the reflected beam, and when we are rotating the polarizer, then what will happen? When polarizer is parallel to the plane of polarization, intensity transmitted is maximum. As you are rotating, Malus law, intensity will start decreasing. When both become perpendicular, intensity becomes 0. Again, still you are rotating, again it become parallel, again become maximum. Still you are rotating, again they become perpendicular. When they become perpendicular, again 0. Still you are rotating, again they will become parallel. So then again maximum. So in the one rotation of the polarizer, in the path of reflected beam, 2 time intensity will be maximum, 2 time it will be 0 or minimum, we can say. Okay. If I gave the critical angle is equal to 30 degree, what is the IP? Find IP. Then this type of problem directly we can say what? Sin theta C is equal to 1 by mu. So then theta C you got what? Theta C I gave 30, so mu what you got? 2. After getting mu 2, then we can say tan IP is equal to mu. Then IP what we got? Tan inverse 2. Okay. This is the whole wave optics. Revise the all points of the Huygens principle, what I said. And some they can relate with the critical angle and all concept, means ultimately mu you have to find the IP. Maybe they given the IP, they are asking what is the speed of the light in that medium. So from the IP you will calculate the mu. After getting the mu, what is the speed of the light in the medium? C by mu. Okay. Okay, then any other thing? Completed? Rafi, you can send the question WhatsApp, I will check. Okay. Okay, then bye bye. Polarizer line, what I said, when suppose this is the polarizer and this is the reflected beam, both are parallel to each other. Okay. Then suppose when it is you put the polarizer in the path of reflected beam, then first suppose it is transmitting maximum intensity, both are parallel, so it transmits maximum. Now when you start rotating the polarizer, then intensity start changing, decreasing, Malus law, I cos square theta. Then when they become perpendicular to each other, then transmitted intensity is 0. Then still you are rotating the polarizer, again it will start increasing. Again when they become parallel, again intensity transmitted is maximum. You will get detect maximum intensity. Still you are rotating the polarizer in the path of reflected beam, then again they become perpendicular, then again it becomes 0. Like that in a one rotation, 2 times 0, 2 times maximum.